Oh, there it is. Good morning. Welcome again to CSC 565, the IT Integrative Capstone. Thanks for being here. This evening, what I want to do, well, first we got to see the comic. It's really far away. I know you can't see it there. Person tells Dilbert, I played golf at Pebble Beach over the weekend. Dilbert says, I played that course on Xbox. That's totally different. I used a full spectrum lamp to simulate sunlight. I got fresh air. You should get a house with windows. They're terrific. Thanks. What I want to do today with you is we've covered already much of the so-called front end of the system development life cycle. The requirements as the first phase in the SDLC, and then specifications as the second phase in the SDLC. So we've talked about those two in depth, and those two are what most folks refer to as the front-end development processes. What we're going to do today is turn our attention to the so-called back end. We're going to talk a lot about design. I'm going to talk around design a lot and try to give you some resources there. Now, for those of you right now on campus, the first time we meet in March 2013, most of you are still working on either requirements and or specifications. But as I've mentioned, and I'll say this to you at a distance in time and space too, you don't have to wait. Continue to move back and forth throughout the software development life cycle. If you ever tell yourself, well, because I'm not exactly sure what the requirements are perfectly at this point, I can't move forward, that's a mistake. You can always do prototyping. You can always do proof of concept work. You can always be working on various aspects of it. It's the nature of the software development life cycle that we are always moving back and forth. If you ever find yourself stuck and saying, well, because the user didn't tell me the specifications or I didn't get feedback on the prototype, I can't do anything, that's incorrect. There's always a lot of either investigatory work you can be doing, or there are aspects of future phases in system development that you could be exploring also. I'm done talking about requirements and specifications. You may not be done with that. And at this point in time, I've given everybody who submitted their specifications some feedback on that. So be sure to listen to that. By the way, this time on Angel, what I did is I just recorded my feedback. So I don't even know if Angel allows you to select that link or not, but you may have to copy that link and just listen to it somehow to get my feedback on that. And then after you process that, if you have questions, I'll be happy to share that with you. In deference to the folks here on campus, for those of you at a distance, I'm going to cut the video feed here so I can get up, move around, actually see people, etc. Can I do that? I can. Very nice. Okay. Let me talk in general about what the system development life cycle is all about. You've seen all the phases, and we've talked about the first two in some depth, but it might be worthwhile to go back and just review the kinds of things that are going on in the system development life cycle. For example, what is it? The SDLC is a structure. It's a framework. This is the process that we're going to follow in order to carry out our project. Our ultimate goal is to produce an acceptable product, and the system development life cycle is the process that we're going to follow. So it's a framework, it's a structure, it's really what we're going to do to figure out what we're doing. The other thing that the system development life cycle is, it's really a way to manage and monitor a project. If you want to let somebody know how the progress of your project is, you would let them know by telling them this is the phase and or the subphase that I'm currently working in. Now, it's true, we do move back and forth, but ultimately we're going to be focusing on something. So If you told your boss that I'm currently finishing up the specifications phase, that would give them, your boss, some useful information. On the other hand, if your boss asked, how's it going, and you said, fine, that's not any information. Nobody knows. So the system development life cycle is not only the framework or structure for the process that we follow, but it's also a way to manage and monitor the project itself. It's a way to, for folks from the outside who may not actually be doing the work but very interested in the work, to know how things are going. First day, I reviewed with you the big picture of problem solving. And way back when, in the first courses in our curriculum, we talk about solving problems in the context of 4 very simple and abstract phrases. So, first aspect of problem solving is to understand the problem, and then to plan the solution, and then to create the system, and then finally to test what we've developed. There are a couple problems with phrasing it like this. One of the problems is this in no way tells you how to carry out these steps. If I tell you the first thing you need to do is understand the problem, that's just declarative in nature. I'm just telling you what to do. I'm not telling you how to do it. Well, that's a problem. That's why the system development life cycle is much more procedural in nature. It's not just going to say understand. It's going to talk about a problem definition and then how to carry that out. So one of the problems with this big picture of problem solving is it talks about the what, but it absolutely doesn't talk about the how to do it. The other problem with this simplistic picture is it also leads you to believe that it is just sequential in nature. You know, testing, well, you can't test the solution until you have the solution, and you don't have the solution until you plan. So it looks like this is very sequential in nature. What system developers call a waterfall approach. Just do one, and then the other, and then the other. That's not how system development actually happens. Although we have this framework, as we saw in the SDLC, it's not like you do requirements, do them completely, and then move on to specifications. You'll be moving back and forth. You're going to simulate that in the project that you're doing, and as a matter of fact, I'm forcing you to do that because I'm very purposely dragging my feet on both requirements and specifications to hopefully ignite a fire under you to say, well, I just can't wait any longer. I've got to do some aspects of this. I got to move on to some other phases, or I'll never get anything done. That's right. It's not linear. It's not sequential. So if you're still waiting because you say, well, I mean, you didn't respond to this question about my requirements, don't worry about that. Yes, it ultimately needs to be accomplished, but much of what goes on in the middle of software development is very messy. It's back and forth. Okay? This looks really clean. It's never done like this. All right, I did that before. I'm not going to go back to that aspect. Now, let me summarize what I'm trying to tell you about system development. System development is part algorithms. There are some rules here. For example, if you're going to create a system, and some of you are creating systems, if you're using a programming language, you have to understand the syntax and semantics of that language. For others of you that are doing perfective system development, I'm trying to remember if I used the terms perfective, corrective, adaptive before in some of our models. But many of you are doing a perfective type of project, which means something exists and works today, it's just not the way that the client wants it. So there's a server, and it runs, but it doesn't do what the client wants. That's a perfective project. And if you're doing that, then you're in the constraints of that particular system, whether it's, the Mac OS or whether it's Windows Server or whatever. There are some algorithms that you have to understand, and you have to work in those constraints. There are rules when we're working with technology. But there's more to developing a system than just saying, okay, here are the rules for the software that I'm going to develop. System development is also part heuristic. Heuristic is a guideline. Sometimes people say a heuristic is a rule of thumb. Unlike an algorithm, which is extremely precise and detailed, heuristics are much fuzzier. This is how we solve problems. We have to think about it. We have to reason. Sometimes we make a guess. Sometimes it's trial and error. Heuristics are guidelines. And although systems themselves, every piece of technology has to follow an algorithm, developing algorithms is not algorithmic. There are no rules for here's how to do this project. And I think by this time you've all experienced how uncomfortable that is. Because I know many of the questions that you have are, well, how do I do? What do I do? How do I do this? Exactly. That's part of the heuristic nature. What you have to do in your project is you have to follow some internal guidelines. You have to think, well, how am I going to approach this problem? What is needed to solve this problem? What does a good solution look like? And answering all those questions. So there's a lot of human thought and struggle and sweat and tears that go into developing a system. Part algorithm, part heuristic. You know what? There is some science involved here. The system development life cycle was originally devised as a scientific process for the development of a system. In operations science, in fields like chemistry and physics, etc., there's a so-called scientific method, usually originally attributed to Francis Bacon. And the scientific method goes something like this, where you collect some data, you evaluate that data by testing it, you evaluate your tests and you formulate a hypothesis, you collect more data, you repeat, you repeat, you repeat. You get to a certain point where you feel very confident in the hypothesis that you've put forth, and then you change that into a theory, and so it goes. Well, the system development life cycle is the scientific process that was developed in the IT profession to do a similar kind of thing, and that is to understand the nature of problem solving and to solve it. But developing a system is not just algorithm and heuristic and science. There is some art here too. One of the things that usually we find interesting and exciting about information technology is it's a very creative endeavor too. Very often you get to put your own stamp on the product that you're going to produce. Somehow the product that you produce reflects your ideas, your aspirations, your knowledge of the system. We're not all doing a programming type of project. I'll just use that to illustrate, but it applies to any project that you're working on. If you think about the programming process, when folks outside of IT ask me, so programming, what is that all about? And what I'll say succinctly is programming, what it does is it captures the human problem-solving process. What programming is all about is capturing the way you think about solving a problem and putting that into a system. Right? In other words, think about any of the little programs that you did in CSC 535, 835. I don't know what Dr. Lippman had you do. You know, a program to develop change or something like that. Whatever kinds of thing you did. When you developed that program, here's how it worked. First of all, you thought about, how would I do that? How would I solve this problem? And then you changed the idea that you had into Java or C# or Objective-C or whatever language he was using that time when you took it. Developing a program is certainly part art. It embodies some aspect of us, well, how we think about solving the problem. And that's a very, I think, satisfying aspect of IT. There's something from us that's in that system, and I can see it. All right, but we're not done yet. Part algorithm, part heuristic, part science, part art. And yeah, a whole bunch of creativity also. IT is, at its heart, a creative endeavor. Unfortunately, some aspects of IT can seem very mechanical, very rote, very mundane. But in any kind of solution, well, let's put it this way. If I asked all 15 of you to solve the exact same problem, I'd be very surprised if any two were identical. As a matter of fact, I might be concerned. She just copied from each other. The odds of two people coming up with the exact same system to solve a problem in IT are not high at all. Now, in general, they need to solve the problem, but see, this is where the creativity comes in. Mine will do things a little differently. I'll focus on some other aspect a little differently. My website will be prettier than yours, and so it goes. Now, on the one hand, developing a system, can look overwhelming. There's a lot involved here. But on the other hand, just realize that all these sort of fit together also. There are some things that we have to pay specific attention algorithmically, but other things we have some free reign, some creativity too. I don't think that on the first day we talked about these, and I do want to talk about it a little bit because it's very possible that you may encounter this as a working information technologist. SEI, the letters stand for the Software Engineering Institute. The Software Engineering Institute is a quasi-governmental organization that currently is housed on the campus of Carnegie Mellon University in Pittsburgh, Pennsylvania. When it was originally begun a number of years ago, it was originally funded by the United States Department of Defense, and the goal was, well, let me back up. The problem was, we noticed that when folks developed IT systems, they weren't always perfect. There's a surprise. Sometimes there were problems. Many times there were problems. The standard problems in system development. Now, these are, if you took the 45-50 sequence, and you've heard this before, but it's not required. The major problems with system development, historically and currently, are A, they're behind schedule, they take too long. B, they're over budget, they cost too much. And C, they're full of bugs. They don't work right. Well, when the United States Department of Defense noticed this trend, they said, well, what's wrong? How do we solve this problem? One of their answers was to set up this organization, the Software Engineering Institute. And their charge was, first of all, to figure out what's wrong with software development, what's the problem, and then what can we do to solve that problem. One of the first things the SEI did is they said, okay, let's investigate organizations that currently develop IT systems, and let's see what makes a good organization versus a bad organization. Do I have the link here? Okay. We'll go to that in just a minute. If you're interested, here's the URL for the SEI. The CMU there is Carnegie Mellon University. They're an educational institution, so that's why it's in the EDU domain. And what the Software Engineering Institute did is they said, let's take a look at all these organizations that develop systems, and let's see if we can somehow group and rank them and figure out those who don't do it well, why not? And those who do it really well, what are they doing right? What the SEI focused on was process. The SEI said, if you want to make a good system, a good IT system, you want to focus on the process that's being followed. So really for them, it's all back to that science aspect. You know, here are the steps. Follow these steps. You can do a really good job if you follow these steps. I think I have to jump there. Yep. Let me just go to this site. I can't remember if I've got to qualify it with www or not. No, it did it. If you're interested, and I would certainly commend this to you because, quite frankly, a number of different IT organizations do take a look at what the SEI is doing. Now, the front page here has just a lot of different stuff on it, and, you know, it may not be very valuable to you. You really have to drill down a ways to find the interesting stuff to us. If you're wondering, you know, what do we do? Here's all the stuff that they do. Acquisition, security, software development, system design, process management. Today, you'll notice that many companies that develop software or develop systems take a look at certifications. I don't want to interrupt. There are a lot of companies that take a look at certifications. For companies that do work in the European Union, typically they have to have a certain ISO certification. They have to have their process identified and understood well enough to be ISO certified. At one time it was the ISO 9XXX that were all the certifications for software. There are some other ones now. But this is something very similar. The SEI's work in process management supports data-centric approaches to advance the discipline of software engineering. Now, you know, we don't use the term software engineering because we're not just focusing on development of software. We develop systems, IT systems. But these kinds of aspects and processes and goals, etc., are still applicable for us. So I'll commend the SEI to you. It's nothing that you have to do as part of your current IT capstone project, but it's something interesting, and I think because you're involved with a process right now to develop a product, that you'll be able to get some useful information out of that. On the first day I told you, here's how we're going to assess your project. A successful project, both in this class and the real world, produces an acceptable product. In the world of information technology, this is what counts. How do you know if you have a good project? Answer, you produce an acceptable product. And on the first day I asked you, acceptable to whom? And I think you all said, to the user, to the ultimate client. And you're right. You measure the success of your project by whether or not your client and user says, yes, that's exactly what I was hoping for. When you're all done, what you hope to hear a user say is, you know, 14 weeks ago, when we just had this sort of idea of what to do, what you came up with was exactly what I needed. This product that you produced is exactly what I need now to be more productive, more efficient, to solve my problems, etc. On the other hand, if your client or user at the end says, what is this? This doesn't help. This isn't related to what I thought the problem was. This doesn't look anything like I envisioned a solution to be. That's not good. If the product isn't acceptable to the user, then it doesn't matter how well documented it is, what kind of process you followed, what kind of certification you have. It just doesn't matter at all. If the end product is not acceptable, it was not a successful project. So, of course, in the world of IT, you want to always make sure that whatever you do, the user and client understands. You have to manage those expectations. The system development life cycle was originally scientifically designed to be a solution to the so-called technology crisis. The technology crisis is just what I shared with you, the fact that IT development was behind schedule, over budget, and full of bugs. The system development life cycle then was supposed to be the solution. If you follow this process, then you can solve the problem. Now that's absolutely helpful. But at the same time, if you don't produce something the user wants or needs or desires, it doesn't matter what process you follow. Okay. First day again, just by way of review, and I think it's appropriate now because now that you've been involved in the system development life cycle and you've thought deeply about two phases and written and et cetera, in those, let's make sure we don't lose sight of why we're doing that. Why am I writing this documentation? It's not just to fill up 50 pages at the very end. I mean, there's a real reason why you're doing this documentation. And that's to manage all of these phases, all of these deliverables, like the requirements doc and the specifications doc. They're really part of management, managing the process. Example, when you do system development, you have to manage expectations. The user already has something in mind. Even if they can't express it, draw it, they still have something in their mind that says, this is what I believe would be a good solution to this. Our job as IT professionals is to ensure that we, A, understand the expectations of the user, and B, distinguish the realistic ones from the unrealistic ones, and then C, make sure that we set the expectations and say, yes, you know, we can do this, and we will do this, but this aspect, that's beyond the scope of this particular project. We can't do that. Managing expectations is a big part of the system development life cycle. That's too obvious. The system development life cycle, thirdly, though, is all about the management of people and their skills. If in the production world of IT you find yourself working as part of a team, then you might have to deal with other people and their skills. But this also talks about you. It talks about such mundane things as time management. And I mean, of course, you're remembering to write down the amount of time that you spend on this project, etc. But it's really, again, the system development life cycle is a way to help us manage either myself or other people and their skills. One of the major aspects of that, of course, is time. You can use the system development life cycle just like your manager can by taking a look at it saying, well, if I'm in phase 2 out of 5 right now, and I've been spending 2/3 of the time already, I wonder if I'm actually going to get through the entire process. So it's a way to help manage that expectation of how much time it's going to take. In the production world of IT, the system development life cycle is used to manage cost also. In actual system development life cycles, you would estimate the total development time, the total developer cost. How many people need to be involved in this project for how long? The system development life cycle absolutely manages other resources too. To do this job in this amount of time with this amount of cost, what kind of equipment am I going to need? What other resources are necessary to carry out my process? Okay, I'm not going to do that. Hey, let's do this. I can't start the project because the user won't give me his requirements. Start making something anyway, otherwise we'll look unhelpful. So our plan is to cleverly hide our competence. You think too much. The front end, thank you. The front end of the system development life cycle. And what many people do, you know, we've talked about 5 phases. We've talked about requirements. We've talked about specifications. We're going to talk a lot about design today. We will get to that. Then there's an implementation phase. And then finally there's a maintenance phase. The maintenance phase is the one phase that we'll just have to pretend. We will not actually get to that. But in looking at these 5 major phases, many people sort of draw a line between specifications and design. The first 2, requirements and specifications, then, many people will refer to as front-end development. The front aspects, the front parts of the system development life cycle. Requirements is part of the front end. And it's where we're starting to set the stage. Specifications, then, is the second phase, and that's also front-end development. I did no work this week because I judged the user's specifications to be inadequate. Should I continue to do nothing, or do you prefer I use incomplete specs to produce useless designs? The next thing you hear is something called leadership. What Dilbert is actually pointing out, though, is the purpose of the front end. And each of these is absolutely related. Wally in the cartoon said, hey, would you rather that I use incomplete specs to produce useless designs? The specifications are going to feed into the design. The specifications come from requirements. Once we have past this dashed line, past specifications, now we're into what many people call back-end development. The back end of the system development life cycle. The design phase then is the first aspect here on the back end. So let's talk about design and see what that is all about. In a nutshell, in the most abstract way, this is what design is all about. Answering this question, how will the product solve the problem? In requirements, we focus on the problem. And the key word is why. Why is there a problem? Why do I need a computerized solution? Specifications, we focus on the what. What does a good solution look like and do? What are the features? What are the functions? What's the input? What's the output? Etc. Now that we have the whys and the whats covered, now it's time to figure out how. Up until this point, we could say, this is what I wanted to do. But now we actually have to figure out how is it going to do it. Here's where a whole bunch of creativity has to funnel in to create all those algorithms that we need a system to actually carry out. In the design phase, most development projects have two subphases. It's possible for some of your projects that you don't have to divide it up this way. But most will have two subphases under design. The first is architectural design. Think of this as high-level design. The word architecture, when applied in a non-IT way, I mean, people are talking about the appearance of a building. The architecture is what I can see. It's how it looks, etc. And that's similar to what we're talking about here. When we break up a project, a big project, into little pieces, we have to know what does each little piece do and how do these little pieces interrelate to other pieces. That's going to be architectural design. Thinking about answering the how question, but thinking about it with modules and how those modules will interrelate. A second subphase of design is detailed design. Detailed design, maybe as the name implies, is kind of at a low level. If I go back to my building example, this is the part that you don't easily recognize. You know, it's how is the foundation created? And the internal support, is it steel or something different? And how was the whole structure then created that everything else was put on top of? So architectural design gives you, if you will, a bird's eye view of the entire how of your ultimate product, whereas the detailed design will focus on each individual piece. How does this module do what it needs to do in order to satisfy the whole? Focus on how, and then oftentimes most people find it easier, if not intuitive, to break it into architectural and detailed design. Design is hard. There's no other way around it. This is the hardest phase in system development. The design phase is hard. So, what do we do in order to help with the difficulty inherent in design? We've already talked about and actually used this We're not going to give up on prototyping. Just because you create a prototype once doesn't mean you're done doing that. In most actual IT development processes, you're going to prototype a lot. You're going to come up with more refined and better and more understandable prototypes illustrating exactly what your product is going to do. Now, as I mentioned before, I know it's most natural to think about a prototype when you are developing a system that is going to actually, be an app, for example. Because a prototype in that case could be screenshots, it could be the user interface. But you can prototype any kind of product. A number of you are doing informational types of projects, whereby the ultimate output, the ultimate goal here is to produce informational documentation that describes a system. Well, you prototype that by showing this is an example of what the documentation might look like and exactly what it would specify. Now, if you're investigating something, today you don't know the answer to that. But that doesn't mean you can't have the structure for it. For example, let's say the project was you need to investigate speed issues related to clients on a network. Now, you don't know how fast today those clients are going to respond in the network environment. You don't know how many seconds it will take to load the operating system if there's no load on the server versus a half load on the server versus a 98% load on the server. We don't know any of that today because you haven't done the investigation. But at the same time, you can create a prototype document that says, now, if I showed you this, and again, you just make up the data. If I showed you this, that, hey, client X, time to boot, so many other clients, would that be helpful to you? And the user would say yes. If you can show me the exact time from push the power key to have the operating system up in memory there, then that would be a useful data point for me. So prototypes don't have to just be something that looks like an app or code. You can prototype anything. Documentation, all the way up to an app. I mentioned proof of concept before, and I'm still going to encourage you to do this. Proof of concept is just saying, in order to verify that I can actually do some aspects of this project, I might have to go do it to make sure I can. That's a proof of concept. Now, of course, when I say do it, that sounds like implementation. Yeah, you're right. And that would be far ahead of design, or at least ahead of design. But the point is, if I cannot comprehend at all how I would tackle or approach this one aspect, then just go try it. Do it and see what happens. If you are creating an application package, then you might have to prototype some aspect of it to see, oh, I said it needs to sort records that are saved in a linked list. Is that possible? How do I do that? You might have to conduct a proof of concept to show, to demonstrate that, yep, this can be done. That's part of design. This is an aspect of design that nobody welcomes, but it's pretty important. Hard part first says, as you might surmise, when you're confronted with doing design, you should begin with the hard aspects of design. That is not human nature. Typically, we would like to do the easy parts first. Why? Because they're easy to do. If your project was to develop a website and you needed to, let's say, maintain inventory, and you know that the hard part is coming up with the data structure that will allow your front end to easily query the database and pull out all the information that you want. But instead of focusing on that first, you start drawing up what the user interface looks like. Because that's easy, and it might even be fun to you. Well, try to avoid that. Hard part first says, in design, you want to focus on those issues which you know are going to be difficult. Why? Well, A, you need to get going because they are going to take a while. You need to invest the time up front such that you can do it. And B, let's say it turns out that you can't solve that particular problem. Well, you'd like to know sooner rather than later to either renegotiate with the client and user or then start some other approach to it. Hard part first, counterintuitive, but important. With everything we do in information technology, there are always trade-offs. Simplistically, you know that if you wanted to buy a piece of technology, whether it was a mobile device or a printer or anything in between, there are always trade-offs, right? For example, let's say we wanted to purchase a new printer. Well, what are all the parameters that a printer might have? Speed, color versus black and white. Yeah, okay, yeah. Power consumption, duty cycle, did I say pages per minute, whatever? All those things are going to be traded off against cost. Right? If you want a high, let's say we're talking about a dot matrix laser printer. You want really high quality, so you want 2400 DPI. You'd like to have color. You'd like it to spit out 50 pages a minute. You know what? That currently is going to cost you a little bit of money. You have to trade that off. If you have an unlimited budget, then there's no problem. You just buy that very expensive but highly competent printer. On the other hand, if you're constrained by cost, and most of us are, and most projects are too, then you're going to have to do a trade-off. Okay? I can't have both fast and high quality. So which is more important? Is it more important to spit out 50 pages a minute? Or is quality more important? Well, again, I mean, you could say anything, but it really depends on what the problem is, right? Exactly. The point is, there's always going to be trade-offs. When you are doing design, you are going to come up with a number of trade-offs. You are going to come up with a number of alternative designs that you could implement. One of the issues in design in the system development life cycle is you should list those alternatives and you should discuss the trade-offs. There's nothing more frustrating to somebody trying to maintain a product than to go back and look in a design document and not discover any of these alternatives. You're trying to update a product and you want to know, why did they do it that way? Why did they choose that data structure? That doesn't seem to make any sense to me. And then you look in the design document, it doesn't say why they picked that data structure versus something else. It's important to discuss these trade-offs, and you'll do that typically in your design documentation. Why did you choose one approach versus another? When you are designing a product, one of the things that separates a good IT professional from just people who do IT is a good IT professional can, quote, think ahead, end quote. In other words, you're considering possibilities, you're considering alternatives, you're putting yourself in the user's place, and you're saying, what if? What if the user did this? Now, one way that you can do that is to consider these two ideas, slips versus mistakes. This is some concept we talked about in the 20 class, in the human-computer interaction class. And again, I'm not expecting you to be able to dredge that out of your mind instantaneously. But slips and mistakes are just the two general categories for errors. User errors. Users are going to do things incorrectly when they're using your system. It's going to happen. A good IT professional plans for that. A good IT professional says, what could possibly go wrong here? And then thinks about how to work, how to deal with that, how to either prevent it from happening in the first place or minimize the impact of it afterwards. Now, let me review with you the difference between a slip and a mistake. Both of these are kinds of user errors. Okay, let's have a context. Let's say we're going to work with an application package, and we're unfamiliar with it. You know, it's a brand new. We work in retail business. This is an accounts payable package. I'm going to use that to pay my suppliers, etc. Okay, so I'm not a new user, but I've got a brand new system here. It's different from what I used in the past. First of all, if you believe that the user is never going to make a mistake with your system, that is a mistake. It's just going to happen. Users don't do it on purpose, but you've likely made mistakes and slips with systems, and so too will users. Okay, here's the difference. A slip is something that happens subconsciously. A slip is something that happened that if you would have stopped to think about it, you wouldn't have done that, you wouldn't have made the mistake. It's either A, you were preoccupied, or B, you were too busy, or C, you were too fast, and you just started doing something, quote, without thinking, and something bad happened. An example of a slip. So you're cleaning up icons on your operating system desktop, and you start moving things around, and you're not paying attention, and you throw an icon, and it goes into the trash can, and it's gone. And you say, darn, I didn't mean to do that. If you weren't so fast, you know, preoccupied or whatever, you wouldn't have done that. So a slip is something, you knew what you did wrong, you just subconsciously missed it. A mistake, on the other hand, is deliberate. Thank you. Now you're saying, why would I deliberately make a mistake? Well, here's where the word means something a little different. It's not that you said, okay, today I'm going to go screw up. There, I did it. By a deliberate mistake, what we mean is you get to a point in your software and it prompts you for something. And you read that prompt, you read the message, and you say, I don't know what that's saying. And you get two options, yes or no. And you're really not sure. Oh, man, I know what I want to do, but I really don't know which option to choose. So, okay, I'll pick this one. And guess what? It was the wrong one. Darn. Exactly. As an IT professional, First of all, you need to be aware of this. And secondly, you need to do things to plan ahead. The standard way that slips are caught is by confirmation. You know, in a system, if you went to delete something, almost always you're going to get a pop-up window that says, "Are you sure? Are you sure you want to delete this?" Yeah, right? That's to prevent a slip. And you look at that and say, "Oh, no, darn it. Thank you, I didn't mean to do that." Okay? So preventing slips is oftentimes accomplished by user confirmation. There's a dark side to that. It starts to get a little onerous, right? If every time you select a command it says, "Are you sure?" For example, Angel does this in the most stupid places. Angel will tell me no matter what I'm doing, "Are you sure you want to quit this area? If you do, you'll lose everything." Well, I just saved it, okay? So you don't need to bring that up. I'm not going to lose anything, but that gets annoying too. Now, mistakes need to be handled in a different way. A mistake is not a subconscious, but a conscious, deliberate mistake because I didn't understand. I didn't understand what the system was saying. I didn't understand what I could do with the system. Mistakes are solved with better prompts and help. If the prompt isn't understandable by the user, you ask yourself the question, why not? And then provide some help. The user says, I don't know what I want to do. What are the outcomes, the ramifications of saying yes versus no? And then the ultimate way that you prevent mistakes is you may not be able to prevent them up front. But when the user makes a mistake, you allow them to backtrack. Can you undo? Right? So in the word processor, you execute this very complicated format painter thing. And suddenly your document looks like garbage. You know, 50 pages and it's, you know, a one-letter column all the way down there. What? What do you do? Well, you didn't prevent it, but you better allow the user to undo it, right? Control-Z in Windows, very nice, very nice. The ultimate thing for us to remember at this point in design is you want to think about these things. And one of the things that both Professor Hoppe and I will be looking at in your design document is, have you talked about this? Now, everybody's is a little different. I know not everybody is creating an app, but you can still think, no matter what your project is, how can I make life easier for the user? How do I prevent or recover from either slips or mistakes? The UI design would only be applicable to those of you that are doing an actual system development thing like making an app or finding apps, etc. Those of you with the informational ones, I mean, there's not truly a user interface beyond what's already provided by what you're investigating. But UI design is part of the design phase also. If you were creating a website, the user interface, how the look and feel of the website is absolutely part of design. But notice that's not the only part of design. Sometimes people think, oh, well, how my software looks is design. Yeah, it's part of it, but not the only part, and that's why I kept it until almost the very end here. One of the founding fathers of system development was Fred Brooks. Eons ago, in both the 501 and 505 classes, I had you read different articles by Fred Brooks. You may remember a little bit about the mythical Man Month and some other things like that. Fred Brooks' latest major treatise was a book called The Design of Design. Kind of a funny title, but intimately appropriate for IT professionals here. Much of his work is available online, and again, this is not a specific requirement for this course, but I think because you're all going to be IT professionals, that you might find some of the things that Brooks has to say here very practical. So this is his book, The Design of Design. Copyright 2010, so very recent. You can actually read a lot of the book online at Google Books here. And although, you know, this is not an assignment and there's nothing you have to do as far as your project is concerned, I think you'll find that reading around some of these is actually interesting. You know, especially these first couple chapters. The collaboration one is not as important to us. Some of these issues in design perspectives are interesting. There are a lot of case studies there, so the actual practical stuff. But really taking a look at the design question, if nothing else, I think you'd find that interesting and appropriate. So, again, the book is The Design of Design. The author is Fred Brooks, and you'll find that online at Google Books. Okay. Where'd it go? There it is. Oh, no, that's not it. Here it is. There. Go. Oh, that doesn't go? I gotta go. No. I gotta go here. I gotta go there. Loading. All right. Let's take a break, shall we? Stand up, walk around, come back in 10 minutes. Welcome back. We're in the midst of talking about the design phase and some issues for that. One of the things that I've tried to share with you when I've given you feedback either on your problem or your requirements or your specifications is that you need to be precise. We've used the terms before, detailed and unambiguous, and a number of you heard me reiterate that for the feedback on the specifications. Trying to be precise is difficult, but it's also necessary. Design's the same thing. The reason that we want design to be rigorous and precise and detailed and unambiguous is because this is really the blueprint, if you will, for implementation. If design is done well, then implementation is straightforward. A lot of times people bypass the design. They say, well, I don't want to spend time thinking about the product and how it's structured. I'd rather just make the product. That is always a mistake. Design ends up being the blueprint, if you will, for implementation. If you consider the creation of a building, very few competent builders would actually construct a building without having a blueprint. The blueprint would indicate here's all the materials that you need, here's the relationship among those materials, here's some order in which materials are put together, etc. You know, dimensions and everything else. Without that blueprint, then, the actual construction may not run smoothly. So design sometimes seems like something that people would say, well, I don't really need to do this, it's not necessary. It is meant to be the necessary prerequisite step for implementation. Implementation is easier if you've done design well and right. The terms that I've applied, detailed, effective, unambiguous. Detailed means you have to list every step. If you leave a step out of design, then your implementation isn't going to be accurate. You have to list every step. Effective refers to a speed issue. Effective means in IT really accomplished in a reasonable time. Unambiguous then is crystal clear. So all these adjectives get thrown out all the time. It's important, but it's also hard to do. It's hard to be rigorous when you're doing design, but it's very important. Yeah. Okay. The last time we actually met as a class, I mentioned the importance of using some semi-formal, the other term is structured techniques, some graphical techniques, if you will. The Brookshire text, oh boy, I think it's chapter 7 that's entitled Software Engineering, lists some of these. I know that many of you are familiar. Other classes, you've used them. Again, the 45, 50, and even the 55 course are going to make use of graphical techniques like DFDs. So some of you have used them more than others. But for every project, you're going to want to employ some type of graphical representation. This is applied not only for specifications, but it'll also apply to design. For example, a DFD, a data flow diagram. I know it's obvious. I mean, data flow is supposed to show the flow of data through a system. A data flow diagram doesn't really state how. It doesn't have a processing how focus. But at the same time, it's important to see what data might be used at different points in the process. So it's meant to show the logical flow of data through a system. A data flow diagram does not talk about processing. There are no algorithms as part of a data flow diagram. Okay, I keep saying that. Now, different organizations and different people are going to present data flow diagrams differently. One approach is the approach that you see here. A data flow diagram is built of just 4 simple primitives. Think back to 505 when we talked about primitives and algorithms. Yeah. There are just 4 fundamental primitives. A double square is either a source or destination of data. An arrow is a flow of data. This rounded rectangle then is some type of process, and an open-ended rectangle there is some type of store. So for example, this isn't anybody's project, but it could be representative of many of them. When an IT professional creates data flow diagrams, they'll actually usually do so in levels or stages. The most abstract level is oftentimes called the context, or you'll also hear the term level 0 applied to that too. So here's a context diagram, a level 0 diagram. The first refinement, you could sort of imagine this is the data flow diagram for Amazon.com. You're going to order a book online. What happens? Right? Well, notice that this rounded rectangle, and again, the rounded rectangle is some kind of process. When I look at the rounded rectangle, it's not saying anything about how orders are changed and combined with package and credit status. We're just really focusing on what data needs to flow around the system. What a data flow diagram gives you is to help ensure that you haven't missed any data. Do I know everything that would be needed for this particular product? A data flow diagram then will help you answer those kinds of questions. That double rectangle, that double square there, a source or destination of data. So the customer is going to place an order online. The customer will also receive some kind of confirmation or feedback, like an invoice online. These open-ended squares, then, the store of data, think about them as maybe a database or some kind of file with additional XML associated with it. Package data that talks about individual items for sale versus customer data that has all the information about our specific customer, name, address, credit card number, and so it goes. And then the final component, those arrows, again, is the flow of data. So order data comes from the customer. The customer is going to generate that. I want to order this book. Brookshire's Computer Science and Overview, ISBN, whatever, add it to my cart, buy it. Somehow we've got to process that. But at this level, I don't care how that happens. I just want to ensure that all the data is accounted for. Everything I need, what's coming, credit status and other things, what's coming out of there. Now, once you've done this, and that is, sorry, go back here. This is pretty abstract. That's pretty high. Nobody could actually design any part of the system with that high level. But we're talking about following levels of abstraction as a way to design. So here's one aspect of that. Now I take that exact same thing and notice, rather than a single process, now I've got two. So I split up my one process orders into verify orders, valid, place order, etc. I've got more than just those two stores of data. I've added another one for pending orders. Oh, look, I even have another process down here, and so it goes. I've added another source or destination up there. So I have another refinement, and then you'll do that again and again and again and again until you get enough detail such that you know that all the data that I need to solve this problem has been accounted for. This is really high level. This is the major architecture of the system. By the time you get 5 refinements in, you're really detailed. You've got lots of little pieces going from A to B there. No matter what your project is, you're going to need to use some graphical techniques. Many of the projects you're involved with can use data flow diagrams. If you're doing an informational project, you absolutely can. And other development ones can use this fairly easily also. So I'm not saying you have to use a DFD, but you have to use some number of graphical techniques in your documentation to describe the design. This isn't related to those first ones we saw, but I just want to point out there are other ways that people draw DFDs. This here, you notice it's kind of a rounded box here. That was the, what did I call them before? Rounded rectangle from a long time ago. They just got a little head on them. You'll see people draw data flow diagrams differently. Don't let that bother you. Okay, enough of that. Here's yet another way to represent. They're using circles as opposed to rounded rectangles. Rather than a 3-ended rectangle, there's just a top and bottom here for the stores, but same idea. Okay. UML is just a notational scheme, unified modeling language. There are a number of different diagrams that follow UML. One of them is use case. I believe that for almost every project that has been selected this time, you can easily create a number of levels of use case documentation. It's a great way to make sure that you understand what can the user do, and as you're creating these things, you might say, well, what about this? And that will just help make sure you haven't left out any details here. So the purpose of a use case diagram is to get some insight into the behavior of the product. And for those of you doing informational types of projects, yeah, this is very helpful also. The first level that you see here is pretty simplistic. This is for an elevator. And there are typically 2 distinct tasks that a user could possibly do. Number 1, press an elevator button, which would usually be up or down on the outside. Once the doors swing open and you're inside, then you press a button representing the floor. That is likely, maybe, unless it's on fire, and then you got to press another button. It's likely covered all of the aspects of that. Use case diagrams, though, can be much more complicated. And the other thing is there's usually more than just one person involved with the system. Back here with the elevator, we have the only actor is the user, the person who walks up to the elevator and wants to go to a different floor. Whereas in this system here, you notice there are 3 actors pictured, and there's some more off the screen that you can't see. There's a customer that can do certain things, and then there are other actors internal to the company here, some that interact with the customer directly in certain areas, and others, notice, that are doing things outside of the scope of the customer. So you're thinking about what are all of the scenarios to solve this particular problem. What are all the people that need to be involved in this, and how do they interact there? The advantage of diagramming is now this can be an easy, straightforward communication tool between you and the customer. You can sit down with the customer and say, I believe that these are some of the activities that you would be involved with, like getting product information. You'd like to look at our catalog and take a look at our motherboards and compare things. Or, I bet you'd like to add a product to your order form to your cart. Or maybe after you've ordered a product, maybe you want to check the status of it. Maybe you want to place orders, etc. And now you can ask the user, is this the sum total of everything you want to do? The user could say, well, I also want to do this. Maybe you say, well, that's actually part of checking order status. Or maybe you say, okay, I didn't realize that. We're going to add another process for you to interact with there. Of course, the customer won't know anything about the back end of the store, you know, the customer service rep or the shipping department or anything else. But then you'd interact with those stakeholders and see what they had to say. UML is a general way of creating diagrams in IT. Use case, and these have been the specific examples that I've given you, are just follow UML syntax. Okay, we're not going to do that. Even though in your specific project you still have lots of questions about specifications, and for some of the projects there are still some questions dealing with requirements, it's time to take what you know and move into the next phase. It's time to begin the design process. You know enough about the requirements and specifications such that you could deal with aspects of it. If you think back to the heuristics that I gave you, one of those things is hard part first. You all know some of the hard parts of your projects. Most of the questions I'm getting anymore are about the easy parts, and I'm just sort of ignoring those for now. I'll get to it. What you need to do next is you need to think, okay, when I actually do this, when I actually do the implementation, what aspects are going to be the hardest? If you're doing an informational project, you have to ask yourself the question, well, what information would be the hardest for me to get, or the hardest for me to decipher, or the hardest for the user to understand, or whatever it might be. If you're creating an actual product, then again it would be, well, what feature or function of this would be the hardest for me to actually create? Start there. If you're waiting until you completely understand the specifications, you're never going to get it done. With what you know now, you can begin working on the design concurrently with the specifications. Realize that when we're done with this project, your requirements and specifications and design, that will all be updated. It will all be changed. What you originally understood to be the requirements has since changed. and you need to update that. But that's just a continual back and forth flow. The phase after design is implementation. For many, many of your projects, implementation is just tweaking the design and making it better. I just don't think I'm going to talk a whole lot about design, because I think of all the phases, that's the one that you've had the most experience with. There hasn't been a course in our curriculum where you haven't implemented something, whether it was a macro in the 505 course or whatever in any of the other ones. You've actually implemented something everywhere. So that probably doesn't need to be expounded on a whole lot. Now, where are we going with CSC 565? This is week 6 out of 14. So when you do the math, you suddenly discover we're pretty close to halfway. Yeah. So if you're not purposely thinking about design right now, then you're actually a little behind the curve. Next time, we're not going to meet all together as a class, but we are going to meet individually. At least you and Professor Hoppe are going to meet. If you're working as a team or two, meet at the same time. Otherwise, this is not optional like the last one was. It's mandatory like the first time that we did this. You need to meet with Professor Hoppe next time. And he is going to want to see some evidence that you really understand the problem, you have a really good handle on the requirements, and the specifications are starting to firm up, at least to the point where he knows that you can do the design. So you need to prove to him that you really know what the problem is, you really know what the requirements are, and you've got a very good handle on the specifications. So just like last time, you'll sign up for a 15-minute or so time slot, okay? And the one thing I'll say is some of you are working on a project that requires some more intimate access to the resources on campus. Some of you would like to see our servers and other kinds of things, and that you're going to schedule that time with Professor Hoppe. And he's going to actually allow you to go in and touch our servers, etc. He's going to tell you the same thing I'm going to tell you now, and that is these are production systems, so please be careful with what you're doing there, okay? But obviously we trust you to the point that we know that you can work with the systems and not do considerable damage to the systems. One thing that might work out well, although you can set up with Professor Hoppe, is either the half hour before or maybe after you meet in that 15-minute time block, you can be working in our server room, seeing some things and gathering the data that you want. But I'll let you work that out with Professor Hoppe. He'll either post something on Angel, or maybe you'll email him or figure out a time. If you need to actually look at our machines, and some of you do, you can actually look at the servers. I had hoped to set up a prototyping area whereby we could emulate our specific environment in such a way that if something horrible happened and you took down the network, it wouldn't interfere with us. But through my fault, I haven't been able yet to duplicate our particular environment. If we can do that, then that will give you a way that you can work on a completely different system, but the system looks like ours. Okay. Now, again, most of you are not doing a project like that, so I'm sorry. Just ignore what I just said with that. The next time we meet as a class will be 2 weeks, for those of you on campus, will be 2 weeks from this evening. And what I'm going to do at that time is talk about the entire range of documentation, what you need to have available, what you'll submit at the very end. Now, I'm asking you to submit documentation as we go along, and as a matter of fact, the one document that I'm going to really force you to have right is the specifications document. The other ones, they need to be right, but if I don't see them until the very end again, that's okay. The specifications document needs to be correct, especially when it comes to the acceptance criteria. And I gave, for those of you that needed to know about that, I gave you some feedback regarding what I mean by that. So in 2 weeks, when we meet all together as a class, assuming we don't have a snowstorm that night, we're going to talk about what is it that you have to have submitted before, I can remember the day in May, May 3rd, May 2nd. It's some day in May, isn't it? This is week 6, 7, 8, 9. April 1st is 10, 11, 12, 13, 14. May 3rd, 2013, you will have by that date submitted your documentation and provided your final product. Professor Hoppe and I will spend the 2 weeks after that assessing them, evaluating them, making sure they do solve the problem. And for many of you, that means then on May 17th, Friday evening, is graduation. Congratulations. By the way, if you're planning on graduating in May, whether or not you want to walk through the actual ceremony, you have to apply for graduation. And the last date to do that is sometime in March. I forget, it's March 25th. Thank you, Annis. March 25th. So if you haven't applied for graduation, this is what I mean. If you expect to be done with all your courses by the end of session B in spring, you're done with 65 and any other course you're taking, then you hope to graduate this spring. But you need to apply for that. You need to tell the registrar that's your intention. And yeah, I'm sorry to say the registrar is going to charge you an additional fee. There is a graduation fee. No, I don't get it, but somebody does, and you will need that. Now, if you are planning on going through the graduation ceremony, and as I spoke to you before twice, I encourage you to do that. It is Friday evening, May 17th. Part of this process of applying, then you could specify, yes, I want to go through that. And then there are some additional things that you will want to do. You do need to, I don't think we allow folks to rent anymore academic apparel. I think you have to actually purchase some academic apparel. You'll need a cap and gown to walk through the ceremony. Yep, that costs a little bit of money. I hope there's some information on that online, how to do that. Because I have forgotten. I guess there is. Okay. All right. Don't forget to keep track of the amount of time you're spending in this project. I don't want you to make time up. I'm not grading that in the sense of, oh, you didn't spend 20 hours this week. That was bad. I would really like to know how much time you are spending in the development of this project. So that was a very early assignment. I'll have you submit that at some point in time, and then at the end here, I'll have you do that also. Okay? When you take a look online at Angel, I think you can see everything. And so you see ahead, you can actually see the design document and other kinds of things there. And when you submit those first ones, yes, I do give you a grade, but don't panic. That grade really, the number that I give you for that is just so Angel will alert you to the fact that it was graded more than anything else. I'm not giving that a large weight in the final determination of the grade in this course. The weight of the grade in this course is the project. And the two things that I can look at are, number one, the process documentation, and number two, the actual product that you produce. If it's an acceptable product, then it had to have been a successful project. If your client likes the product and says, yes, this solves my problem, then everything's worked out great. So focus on that. Okay. For those of you at a distance, I think that's everything I wanted you to hear about also. I do want to say some additional things to the folks on campus, but I don't think, well, if I'm incorrect, I will come back. But I'm going to tell for those of you at a distance listening in that I think that's the last you'll hear from me today. You have some other templates and things to check online at Angel, so feel free to do so. And thanks for your continuing hard work.